Further, damage identification can also be done using modal strain energy. This is actually a two-stage process. First stage, to locate the damage using change in modal strain energy of the element The second stage is to determine the extent of damage. By iterative scheme. Modal strain energy of jth element of both undamaged and damaged case is given by modal strain energy I j is phi I transpose k j phi I. Modal strain energy damaged case is given by phi transpose damaged I, k damaged j and phi damaged I, where d stands for damage. D subscript identifies damage state. Kj is the element stiffness matrix of jth element. Phi I is the ith mode shape. Change in modal strain energy ratio is indicated as modal strain energy change ratio. Okay. So, the modal strain energy change ratio from j to I is given by modal strain energy I j in the damage state minus modal strain energy I j, the mod value, by modal strain energy I j. Let us say equation 3. Equation 3 is a meaningful indicator of damaged elements. Damaged elements will have a significant change in the stiffness, because stiffness will be degraded. Therefore, change in stiffness for the damaged element can be expressed as a fraction of or a fractional change of elemental stiffness matrix. So, this is given by the damaged K is given by K plus J equals 1 to L delta Kj, which is equal to K plus delta to L alpha j Kj. This is valid for minus 1 less than alpha j less than or equal to 0. Now, change in modal strain energy is expressed as below. Modal strain energy Ij is 2 delta phi I transpose Kj phi I plus alpha j phi I transpose Kj phi I. In the above equation, alpha j is unknown, the remaining all are known actually. Okay. To start with, this is assumed to be 0 and iteration is certain. Thus, modal strain energy correction Ij is 2 delta phi I Kj phi I. Now, the modal strain energy correction or the modal strain energy change can be determined for both damaged and undamaged state. By using the appropriate stiffness and mode shape, is it not? For damage, we will use, for damage case, one can use K damage and phi I damage, is it not? So, in the undamped case, following equation holds good. K plus delta K minus phi I plus delta phi I is 0. Now, delta phi I is expressed as a linear combination of mode shape of undamaged system and is given by now substituting equation 9 in equation 8 and neglecting higher order terms, we get dir is minus 5 bar transpose r delta k phi I by omega r minus omega I for r not equal to I. Modal strain energy change is then given by modal strain energy change is given by 2 phi transpose kj summation r equals 1 to n phi r transpose delta k phi I omega r minus omega I of phi r. Now, the earlier equations, that is 4 to 5 of modal strain energy correction can be simplified as below. Modal strain energy correction I j summation of one to L 2 alpha p phi transpose k j r equals 1 to n phi r transpose k p phi I omega r minus omega I of phi r. For r not equals I, this is also for r not equals I, equation 12. Now, once the damage is located, then damage sensitivity can be determined as below. Modal strain energy correction in I1, modal strain energy correction I2, modal strain energy correction Ij is given by beta 11, beta 21, beta j1, beta 12, beta 1p, beta jp multiplied by alpha 1, alpha 2, alpha p, equation 30, where p is the number of suspected damage sites that is damage locations, J is the number of elements considered to compute the modal strain energy correction. Beta St is given by minus twice r equals 1 to n phi I transpose k s phi r transpose k I phi I omega r minus omega I of phi r for r not equals I, where beta St is the element sensitivity coefficient of modal strain energy correction. Now, modal strain energy correction are experimentally measured and then substituted in equation 13 to obtain the fractional change in stiffness of the damaged system. Or let us say the damaged elements. Once initial value of alpha p as referred in equation 12 is obtained, values of modal strain energy correction can be updated for each iteration until convergence is reached. In this lecture, we learnt how to do damage identification using lumped mass. We also learnt how to do damage identification using element modal stiffness. We have also learnt how to do damage identification using modal strain energy method. We will discuss the further methods in the next lecture. Thank you very much.